All right, this is video 10.4.2, and this one is on solving logarithmic equations by hand. So just like we solved exponential equations by hand, we're going to solve this one by hand. So no technology. We're going to go ahead and get started. I think there's about 4 examples, so let's go take a look. All right, so here we're going to examine the base and the value. Or the exponent and the value. So it all depends on what we're given. In this case, I'm saying that the base x raised to the power of 4 equals 10,000. So what could make that happen? Well, this means that I actually could take the fourth root of the other side. So this allows me to use an exponent method of solving. So I could, or radical method I guess, would be the fourth root of 10,000. When you do that, you technically get plus or minus 10. But my base must be positive. So that means that 10 is my only solution for this one. For the next one, same idea. I have x to the power of 3 equals 8 over 27. I'm going to write it down again. Remember, it's log base b of the value equals the power. B to the power of p equals v. If you understand this relationship, then you can rewrite these very quickly. The power is always what we're solving for. That's the whole point of a log, is to find the exponent. Well, this one says we have the exponent, but we don't know the base. So here I'm looking for what cubed became 8 over 27. For some of you, this is going to be very natural. What I want you to think of is what cubed became 8 and what cubed became 27. The fraction is just two different parts, but they can be treated separately when you're thinking through it. So you may also take the cube root of 8 over 27, and we can look at that separately as the cube root of 8 and the cube root of 27. This time we get x equals 2 over 3. All right, our next example here. Here we're taking a look at the base of 4 with an exponent of 5/2 equals x. Well, since I know the relationship between the half being a square root and 4 being underneath, being raised to the 5th power, this is actually pretty simple. I'm taking a look at 4 to the 1/2 power, that's the square root of 4, raising it to the 5th power, that's 32. Remember, this is 1/2. Let me write that again. It's 4 to the power of 1/2 to the power of 5. The 1/2 becomes the square root. The next one, 49 to the power of x, this is always my exponent, equals the cube root of 7. This requires me to consider the relationship between the x and the 7. And I'm going to take 2 steps to rewrite it. I'm going to say 7, that should have an x, to the 1/3 power. Well, I'm going to think of how I can relate 49 to 7, and that is that I can have 7 squared to the power of x equals 7 to the 1/3, which means 7 to the 2x power equals 7 to the 1/3, which means 2x equals 1/3, or x equals 1/6. Again, all of these were done with manipulation and not a calculator. Great job.